If you are able to hear me, the video should be on. We're going to start the class now. Right. So, as per the plan, yesterday we have already learned the basics of constructive and destructive interference. We are going to proceed from there, and today our aim is to learn YDSE and diffraction, isn't it? That's what the plan is, that's what the aim is for today's class. Today, by the end of this class, you should be having full clarity on how YDSE works and how diffraction works, especially diffraction, which can be sometimes confusing if you don't have the basics strong. Fine, coming back. So, first, before I start proceeding with YDSE experimental setup, the derivations and all these things, I want to check with you how much you remember from the previous class. From yesterday's class, whatever I taught, from there I will just have a check with you. For example, we have learned in the previous class about constructive and destructive interference. If I ask you, Anshul, for constructive interference, what should be the phase difference? What will be your answer? How much ever you remember?
I didn't revise this.
Okay, sit for 2 minutes and revise. Kalai Chelvan, what about you? For constructive interference, also called as bright spot, what should be the phase difference?
25 centimeters.
What you are speaking, man? Phase difference I am saying. We are confusing with ray optics and wave optics. You were there in the last wave optics class, Kalai Chelvan, by the way?
No, sir.
Oh, then you cannot answer this question itself. Leave it. And Preetika, I think she has a network problem. If you remember the previous class, that is yesterday I took a class in the morning time, where I told the phase difference for constructive interference should be equal to 2n pi. Preetika, if you are able to hear me. You remember this?
I attend the morning class.
Oh, that's why you don't know maybe. So you are also not in the morning class. Okay.
We had school, sir.
Okay, fine. I understand. So maybe that's why you have not able to answer this. I have a video for the previous class. I'll share it with you. Then today's class will become more easy for you, because this class is continuing from the previous class. Okay, Preetika, you are there? Preetika, if you're hearing me, just confirm it by saying something. Still, I'm unable to get any response from you. So, just to Anshul and Kalai Chelvan, even you, yesterday we were not there, no? Okay. So, yesterday I taught that constructive interference takes place whenever the phase difference between two waves is 2n pi. 2n pi where n starts from 0, or maybe the delta x is equal to n lambda. N starts from 0, 1, 2, 3, 4, such like that. It means phi should be either 0 or 2 pi or 4 pi or 6 pi or so on. Are you getting my point? Or path difference delta x should be 0, lambda, 2 lambda, 3 lambda, 4 lambda and so on. Put in the formula, you will understand. When you put n is equal to 0 here, it will become 0. Put 1 here, it will become 1 lambda, 2 lambda, 3 lambda, 4 lambda and so on. It means when two waves are having a path difference of this 0 lambda, 2 lambda, 3 lambda, 4 lambda, they are going to interfere and make a bright spot. With these things, whatever I am speaking to you will be very clear to you only if you see my previous class video, which I took yesterday. Yesterday I took a class in the morning. Yes, I put in the group also. Maybe you were on school, I think. You cannot attend the class. So, no problem. I will share the video with you and I will teach all these things once again in the regular class. Wednesday class, I am going to teach all these things. Just some students are having exams, so I am teaching it early, nothing else. And those who have exam, they have not turned up. That is a bad thing. Except Preetika. Preetika, you are hearing me? Please check. Still, I am not. Preetika, you are able to hear me? No, I am unable to hear you. Your mic does not work. Anshul, you are able to hear me, right?
Yes, sir.
Right. So, if I talk about dark interference, destructive interference, which gives rise to dark spot, please pay attention. Then what is the value of phi? Kritika, if you are hearing me and you can respond to this question. Phi should be how much? I don't think she is hearing. Phi should be 2n minus 1 into pi, and delta x, which is the path difference, should be 2n minus 1 by 2 into lambda. But here the check is there. Here the n does not start from 0, it starts from 1. 1, 2, 3, 4, 5 and so on. So when you put the values of n in this, put n is equal to 1 here, you are going to get pi, isn't it? You are going to get pi. Then you put n is equal to 2 here, 4 minus 1, you are going to get 3 pi, you are going to get 5 pi, you are going to get 7 pi and so on. Same way, what will be delta x? Put here 1. 1 minus, that is 2 minus 1 by 2, that is 1 by 2. So 1 by 2 lambda. Put here 2, 4 minus 1, 3 by 2 lambda, 5 by 2 lambda, 7 by 2 lambda and so on. Are you understanding what I have told here now? It means if two waves are interfering such that their path difference is 1.5 lambda, 2.5 lambda, 3.5 lambda, 6.5 lambda, 11.5 lambda, 10,467.5 lambda, it is going to make a dark spot. And if two waves are going to interfere such that their path difference is lambda, 3 lambda, 9 lambda, 12 lambda, 35 lambda, 678 lambda, 10,098 lambda, 1,24,671 lambda, whatever it may be, it is going to make a bright spot. If, or in terms of phase difference, if I say, if two waves are going to interfere having a phase difference of 0, 2 pi, 12 pi, 36 pi, 3,462 pi, 12,644 pi, 21,45,666 pi, then you are going to get a bright spot. What you should check is only whether it is odd or even. If it is going to be pi, 7 pi, 11 pi, 17 pi, 2,671 pi, 7,469 pi, it is going to make a dark spot. So, you should have clarity on when two waves will interfere and make a dark spot and when two waves will interfere and make a bright spot. If this is clear to you, only then you can understand the concept of YDSE. Young's double slit experiment. Anshul, you are there in the class? Respond if you are there in the class. Pritika, what about you? Could you, are you able to hear me? I am teaching, so I want to confirm whether you are able to hear me or not. Yeah. Okay. Are you able to respond something, unmute and say something? I will check whether you can interact or not. I am unable to hear you. There is some issue with your mic, I think. Okay, if you have any doubt, you can put in chat section, no problem in that. But interact, learn since you are attending the class. Anshul, what about you? You went for having your lunch? Anshul, you are also not audible to me. Please check everybody. Anyhow, now what is YDSE? I said you in the previous class, yesterday's class, that it was Huygens who first proposed wave theory of light. Huygens told that light is not a ray, it is a wave. But the world did not accept. Everybody told that it is not possible because Newton gave corpuscular theory which told that light is a ray. World has more belief on Newton. They accepted light is a ray. They denied light is a wave because when in 1800s Newton told light is a ray, same time Huygens told light is a wave. Nobody accepted. Until his students, his name was Young. He did an experiment and proved that light is a wave. Are you getting? That's why the experiment name is Young's double slit experiment, because Young was the student of Huygens who experimentally proved that light is a wave. How did he prove that? For that, let me tell you the setup. He took a board and he made two slits on that like this. Okay, slit means a cut. And behind this, he had a screen. This is screen, this is slits, and in front of it, he kept a source of monochromatic light. Source of monochromatic light. Monochromatic means single color. If it is blue, it should be blue. It should not be white light. And then he kept a convex lens in front of it to make it strong beam of light. Okay. I think I told this in the yesterday's class also, that when you have this kind of setup, the expectation is on my screen where I am having a slit, I should have brightness, and rest everywhere I should have darkness. This is general expectation. I am passing light from here, there is a hole, light will pass through hole, and I should, behind the hole I should get a bright spot, rest everywhere I should have a dark spot. Expectation was that. But when we saw it, it was surprising that on the screen what really forms is something like this, where you have a bright spot, a dark spot, bright spot, a dark spot, bright spot, a dark spot, bright spot, a dark spot. This is what was visible on the screen, which made people to rethink that light cannot be ray, because if light is ray, it should go in straight path. If it goes in a straight path, I should have only two brightness. It means light has somehow entered and went in some curved path, which is only possible if light is a wave. That's how Young's, with this experiment, proved the world that light behaves like a wave and not like a ray. Further, if I am going, cause of fringes, which position the fringes are formed, all these things we will discuss now. So, I am drawing the same diagram in a more easy way to see. So, I am going to have like this, these two openings are two slits, I am writing it as slit S1, slit S2. Behind my slit, I am having a screen. So, this is the screen, this is slit. Distance between slit and screen is taken as capital D. Okay. Distance between the slit is taken as small d. Fine. So, what did Young say? Young said that two light beams are not entering like ray. If it would have entered like ray, it would have gone like this, I made a brightness here, gone like this, made a brightness here, and everywhere else darkness. To the surprise, what was observed in the central point, you have a bright spot, then you have a dark spot, then once again you have a bright spot, then you have a dark spot, then once again you have a bright spot. Same way here also, central bright, dark, bright, dark, bright. Are you able to feel how the fringes are, these are called as spots or fringes, bright spot, dark spot, or bright fringes and dark fringes. Okay. Then he started studying how it happened. He concluded that light would have come like a wave like this, and from this slit also waves, and wherever the waves are interfering, they will have some phase difference, isn't it? The phase difference between these waves decide whether it is going to create a bright spot or is it going to create a dark spot. I hope you are getting my point. The spots which are created are the result of interference between the waves, and just now I have told you that interference on the wave, whether it will be bright interference or dark interference, is totally depending upon the path difference or phase difference. So, when two waves are interfering and their phase difference is 2 pi or 4 pi or 6 pi or 8 pi, it is going to create a bright spot. If two waves are interfering such that their path phase difference is pi, 5 pi, 7 pi, 9 pi, it is going to create a dark spot. This was the conclusion made by Young theoretically, that light is not entering like a ray, rather it is entering like a wave, and these waves are interfering, and wherever waves are interfering at phase difference of 2 and pi, they are going to create bright spot, and wherever they are going to enter with a phase difference of 2n minus 1 into pi, it is going to create a dark spot. Okay? I will go to the next page. If you want to copy something, take 2 minutes to copy. If you are copying something, please copy fast. I will go to the next page for the mathematical derivations. Make it fast if you are writing something. And again I repeat, if you are confused between how it has come 2n pi and everything I have derived yesterday, I will share the link with you. See the video today itself after the class and you will get a clarity about how it has come. So I have even shared the video link in the group for Anshul, Kalaichalan and you, okay. Wave optics, first lecture. Go through that, then this will become clear to you. And I hope whatever I am teaching hereafter today also goes inside your head, okay. Shall I go to the next page then? Kalaichalan, Anshul, shall I?
Yes, sir. Sir.
Okay. So now, let us understand the reason for all these fringes formation and location of the fringes. That's how the numericals comes from here. Remember that more than derivations, expect numericals to come from this chapter. And numericals will come mostly to find the location of 7th bright fringe, 8th dark fringe, 27th bright fringe, 11th dark fringe. Like that they will ask you to locate. Or sometimes they may ask you what is the distance between 9th bright and 6th dark. These kind of questions are asked in YDSC. To understand those questions well, first let us understand how the fringes are formed, location of the fringes. So, it is very easy to understand that why is the center point having a bright spot? Because, see here, I will tell you. From S1 slit and S2 slit, if you see the path, that is if I take this point as P, then don't you think that S1P is equal to S2P? Visible to you by geometry? If S1P is equal to S2P, then delta x should be 0. What is the meaning of delta x? Path difference. Both are same. S2P minus S1P or S2P minus S2P will be 0. If delta x is equal to 0, just before some time I told you, for delta x 0, what is the spot? Bright spot, isn't it? So, since the center point has a path difference of 0, there is no doubt that the center point is going to have what kind of spot? Bright spot. Is it clear to you? So, reason of central spot being bright is the fact that path difference is 0 at this point. Is it clear to you? I hope it is clear to you. This was simple. What is the challenging part is location of nth bright fringe. Location of nth bright fringe or spot. Okay. So, now please pay attention. For locating nth bright fringe, I have already told you that distance between the slit and the screen is capital D. Distance between two slit is small d, and always remember that small d is much less than capital D and lambda is much less than small d. These are the conditions for seeing distinct interference pattern. That is, wavelength of light should be much smaller to the distance between the slits, and distance between the slits must be much smaller than the distance between slit and screen. For instance, lambda should be in nanometers, small d should be in millimeters or centimeters, and capital D should be in meters. That is a comparison. Just I am saying you for the understanding. Okay? So, D should be in meters, small d should be in millimeters or centimeters, and lambda should be in nanometers. Obviously, light has a wavelength in nanometer range only, 400 to 700 nanometer. And I will keep some millimeters, 2 millimeter, 3 millimeter distance between the slits, and the screen will be located some 1 meter, 2 meter away from the slits. That is how the setup is made. Now, what I am going to do, you see, my aim is to locate the nth bright fringe. So, for that, first let me find the first bright. So, this was the center point. Here I am having central bright. This is slit 1, this is slit 2, and let this be location of first bright. Why 1b means location of first bright. What is the path difference? Let this point be P. What is the path for this S1P? What is the path from S2? S2P. Do you agree with me? Very clearly visible that S1P is shorter, S2P is longer. There definitely is a path difference. Don't you agree with me? Anybody will say no. S1P is small, S2P is large. So, there is a path difference. And what is the path difference? Path difference is S2P minus S1P. Do you agree with me? To find that value, if I drop a perpendicular from here, see, this and this becomes same almost, this becomes delta x. Do you agree? What I did, are you understanding? I have dropped a perpendicular from S1. Now, this line and this line are approximately same. So, automatically this difference is becoming delta x. One more thing I will say, please pay attention. If I am taking this as theta, from center I am taking this as theta. Do not confuse, please pay attention. Central point is there, now I have joined it from that location, and this angle I am taking as theta. This angle will also be approximately theta. Why I say so? Because these lines are not very far from each other. I said you the distance between the slits is in millimeter. So, if these points are too close, then these angles will be almost same, not exactly same, almost same I am saying. Okay. If so, if this is theta, this will be 90 minus theta. If this is 90 minus theta and this is 90, this will be theta. Have a clarity of the geometry. So, in this triangle S1, S2, let this point be x. S1, S2, x. This is S1, this is S2, this is x, this is delta x, this is small d, this will become theta. Do you agree with me? If you have any doubt, feel free to ask me. This is x, or if x I am already using, I can use something else also. I can use q if you want. I am using point this as q, and this angle I told as theta. Okay. If you have any doubt, please ask me in this diagram, because now I am going to use some trigonometry. If you have any doubt, feel free to ask me. No doubt. What is tan theta? In this triangle, what is tan theta? Or why tan theta? I can take sin theta because I have this and this. Okay, what is sin theta?
Delta x by d.
Delta x by d, isn't it? Now, for first bright spot, what should be the delta x value? Just now we have learnt this is central bright. So, first bright should be lambda, isn't it? 0 is for central bright, lambda is for first bright. So can I say for first bright delta x must be lambda? So can I write from this sin theta for the first bright, whatever I am talking is for first bright only, don't forget that, first bright should become equal to lambda by small d. Do you agree with me? See, understand the logic. Logic is much important here. Mugging up anybody can do, but until the logic is clear, you will make mistakes in numerical. Sin theta 1, that is first bright, will be lambda by d. Do you agree? Do you agree? Before some time, I told you lambda is much small than small d. If lambda is much small than small d, then obviously this number will be very small. Lambda is very small than small d. Lambda by d will be very small value. So if sin theta value is very small, can I replace sin theta as tan theta or theta? Are you getting what I am trying to say? Since sin theta is very small, I can replace it with what? Tan theta. So what I am going to write? I am going to write, in the previous place sin theta was equal to lambda by d for the first bright spot. I am going to write tan theta now for the first bright as lambda by d. How I made this change, you understood? By assumption that theta is very small. Okay. Now coming back. Or also I can write theta of first bright as lambda by d. This also is one expression. Theta is called as angular position. Y is called as linear position. Theta is called as angular position. Okay. If you come in this triangle, the bigger triangle, I am talking about this triangle now. What is tan theta? This is only location, y means this is only y of first bright, yeah. Tell me, what is tan theta here? Y1b by distance between slit and screen is what? Capital D, isn't it? So can I write tan theta as y of first bright by capital D? Is it clear to you? From here I get y of first bright as lambda d by d. Is it clear to you? Angular position of first bright is lambda by d. Linear position of first bright is lambda d by d. Lambda is wavelength of light. Capital D, distance between slit and screen. Small d, distance between the slits. Same way, this is for first bright. If I want to find for second bright, what will change? Nothing will change. Delta x that we took here as lambda, now it will become how much? For second bright, 2 lambda. For third bright, 3 lambda. For fourth bright, 4 lambda. Can I say that for nth bright spot, the theta of nth bright will become equal to n lambda by d, and y of nth bright will become equal to n lambda d by d. Is it clear to you? Any problem in this? If there is any problem, please ask me. Are you getting a point? Where n should start from 1, I should say. Why not 0? Because 0 already I am using for central bright. Central is bright only. First bright at 1 lambda d by d. Second bright at 2 lambda d by d. Third bright at 3 lambda d by d, and so on. Any problem in this? Any confusion in this? If there is no confusion, you can copy it fast without taking much time. Something you are copying, please copy fast. Then I will talk about dark spots. Make it fast, please. If there is any doubt, feel free to ask me. Hmm. Can I go to the next page? Completed? Yes. Copy it fast. I hope you are done. Not only that, if you want to write what will be the location of dark spot, just change it with the dark, no? Like for example, we took for first bright spot delta x as lambda. What you will take for first dark spot? For first dark spot you will take delta x as lambda by 2, isn't it? For second you will take 3 lambda by 2. For third you will take 5 lambda by 2. For nth you will take 2n minus 1 by 2 into lambda. So I can directly write here that for nth dark spot or destructive interference, theta of nth dark will become equal to 2n minus 1 by 2 into lambda by d, isn't it? And y of nth bright will become equal to 2n minus 1 by 2 into lambda d by d. Do you agree with me? I hope you agree with me. So these are the formula to locate nth dark spot. Actually, I should write NB, dark spot. Theta of nth dark, y of nth dark. Is it clear to you? I hope it is clear to you. So let us see some questions how it comes in the examination. Couple of questions to make it strong. Then we will go to diffraction. So take one question, the first one. Please take it. Question is, I am directly giving data to you. Small d is 1 millimeter, small d 1 millimeter, capital D 0.5 meter, lambda is 5000 Armstrong. Find the separation between 7th maxima, find the separation between 7th maxima and 11th minima, 7th maxima and 11th minima on the same side of central maxima, on the same side of central maxima.
Sir, could you repeat the value of lambda loop, sir?
Lambda is 5000 Armstrong.
Thanks.
Maxima is only called as a bright spot, man, and minima is called as dark spot. Whenever you see the word maxima, it means bright spot. Minima means dark spot. Yeah. So before you take this question, I want some more thing to be told to you. See here. If you see, where is the first bright located? At lambda d by d, isn't it? Where is first dark located? If you put here first dark, y of first dark, if I ask you, you will get 2 minus 1 is 1, 1 by 2. So it will be lambda d by 2d, right? Which is bigger? That is bigger or this is bigger? That is bigger, this is half of that. Do you understand that? How the fringes are forming on the screen? On the screen, first you will have central bright, isn't it? Then you will have dark, first dark, I should write like this, first dark. Then you will have first bright, then you will have second dark, then you will have second bright, and so on. Are you getting my point? Same way down also, central bright. So you will have first dark, then you will have, see, I'll draw like this to make it more clear for you if you're confusing in this. First I will make like this, central bright, then I will leave dark, then I will have first bright, I will leave dark, then I will have second bright, and so on. Same way here, central bright, down you have first dark, then you have first bright, then you have second dark, then you have what, second bright. So something like this. This is first dark, sorry, this is first dark, this is second dark. First dark, this is second dark, this is again first dark, this is second dark. Is it clear to you? So if I ask you what the question is saying? Seventh maxima and both are maxima only. Seventh maxima and 11th maxima. So seventh maxima will come from center, isn't it? And 11th also will come from center. This is, suppose this is seventh maxima and is 11th maxima. If you find y of 11 and y of 7 and subtract them, you will get the answer, isn't it? That's all the question is. So what you have to find here is y of 11th bright minus y of 7th bright. What is y of 11th bright formula? N lambda d by d, isn't it? So it will be 11 lambda d by d minus 7 lambda d by d, which will become equal to how much? 4 lambda. Lambda is how much given? 5000 Armstrong. So 5000 in 10 power minus 10. What is capital D given? Meters. Divided by. What is small d given?
1 millimeter.
Solve, you will get the answer. This much meters will be the answer. Do you understand that? I hope you are understanding it. Also, if you want to find the fringe width, what is the meaning of fringe width? Fringe width is distance between consecutive, write it down somewhere here, it is actually a topic. Fringe width given by the letter beta. Fringe width is distance between two consecutive bright or dark spots. Bright or dark spots. It means beta will become equal to y of nth bright minus y of n minus 1 bright. Can I say like that? That is, if you subtract 2 y of 2b minus y of 1b, you will get fringe width. Fringe width of dark fringe. Same way, if you want to find fringe width of bright fringe, it will be y of nth dark minus y of n minus 1 dark. Are you getting my point, what I am trying to say? If you subtract 2 bright, between them you have dark. If you subtract 2 dark, between them you have bright. But luckily, both will give same result to you. Check. Suppose I am doing y of 7th bright minus y of 6th bright. What will be the answer? 7 lambda d by d minus 6 lambda d by d, it will be lambda d by d, isn't it? Are you getting a point? Suppose I am doing 7th dark minus y of 6th dark. What is the answer you are going to get? For 7 you will get 2n minus 1 by 2. So 14 minus 1, that is 13 by 2 lambda d by d. 13 by 2 lambda d by d minus 6 will become 12 minus 1, 11 lambda d by d, isn't it? What is 13 minus 11? Actually 2d will come here, yeah. What is 13 by 11? 13 minus 7 is 11 is how much? 2, right? So it will become 2 lambda d by 2d. 2 gets cancelled. How much you are going to get? Lambda d by d. It means lambda d by d is the formula of fringe width. Are you understanding? Whenever they ask you to find the fringe width, what is the answer? Lambda d by d. If they ask you to find angular fringe width, it will be lambda by d. Angular means you will remove that capital D, nothing else. If you see, you will realize when I am finding y, I am having this capital D. When I am finding theta, this capital D is not there. So the fringe width formula is lambda d by d, and angular fringe width formula is lambda by d. Is it clear to you? I hope you are understanding. Is there any clarity needed? Take another question. Question is, if lambda is 6000 Armstrong, first maxima is obtained at 0.2 meter from central bright. First maxima is obtained at 0.2 meter from central bright. 0.2 meter from central bright. Where will be the fourth minima? Where will be the fourth minima if lambda is 4000 Armstrong? If lambda is 4000 Armstrong. If lambda is 4000 Armstrong. Any answer? Think for a while. Dark fringe formula what? 2n minus 1 by 2 lambda d by d. Why you not wrote, man? I gave here, no? 2n minus 1 by 2 into lambda d by d. Shall I help now? Actually, simple question. No? Why you are not getting an answer? I don't know. Let us solve it. Shall I? Written. What is the question, Yashwant? Y of what is given? First maxima. Loudly read the full question.
Lambda is equal to 6,000 Armstrong.
They are telling if lambda is equal to 6,000 Armstrong,
First maximum is obtained at 0.2
first price is obtained at
0.2 meter from center right.
0.2, okay, meters.
Where will be the fourth minima
Y of fourth dark
if lambda is 4,000 Armstrong?
if lambda becomes 4,000 Armstrong. This is the question. Okay. So what is the formula of one right? 1 lambda d by d. So lambda d by d value is given as how much? 0.2, isn't it? Do you agree with me? So from here I can write capital D by small d is equal to 0.2 by how much? Lambda is 6,000. Do you agree? Do you agree? Let us not solve it. What is the weight of fourth dark? 2n minus 1 by 2. 2 into 4 is 8. 8 minus 1 is 7. So 7 by 2 into lambda d by d. Do you agree with me? So 7 by 2. What is lambda given? 4,000 Armstrong. I should ideally write 10 to the power minus 10 also, yeah, to count in meter. So here also 4,000 10 power minus 10 will come. Into what is capital D by small d? This much. 0.2 divided by 6,000 into 10 to the power minus 10. This 2 gets cancelled. These 3 zeros gets cancelled. 2 becomes 0.1 times. And this 3, this becomes 2 times. So what you are going to get? 14 into 0.1 is 1.4 divided by 3. Whatever comes. 0.34 are 12. 2036 18. 0.466 meters. Is it clear to you? What I have done is clear to you or not? Any doubt up to here? If you have any doubt, you can ask me. If there is no doubt, then we will learn about diffraction in the next session. I mean, I thought of teaching now itself, but already time became 3:30. So I hope whatever I have talked about YDSC is clear to you. And again I am repeating, those who are not there in the previous class, refer the previous session video of wave optics. Then you see this class once again, it will become more clear to you. Maybe some difficulty you may have today because you are not there in the basic class of wave optics. Directly you came from YDSC. If you see the basic class and then join for the session, it will be more useful for you. Okay. So I hope whatever I have spoken today is clear to you. Basically, we have identified what is YDSC. We have found the location of nth bright, location of nth dark, fringe width, angular fringe width, all these things. And next class when I come, we will solve some more questions from YDSC before we start talking about the diffraction concepts. Okay. So if everything is fine, you can drop off. We will meet again in the next class. Take care. Bye-bye.
Thank you, sir.
Yeah.
Thank you, sir.
Yes, yes.